So, have you ever stopped to think about how the internet actually works? I mean, how did we go from tiny personal websites to these massive global services that we all depend on every single day? Well, a huge piece of that puzzle is the database, and specifically the incredible story of how things like MySQL learned to grow and, maybe more importantly, how they learned not to break. Today, we're going to dive into that amazing history of MySQL replication.
All right, let's start with the big question, the one that every developer in the early days of the web ran into. You build a cool website, people love it, and all of a sudden, your one little database server is just melting. What do? You can't just keep buying a bigger and bigger computer forever. The answer, it turns out, was an idea that pretty much changed everything.
And this was it, master-slave replication. The concept itself was just brilliantly simple. You've got one server, the master, and it handles all the writing and updating of data. Then you just set up a bunch of other slave servers that do nothing but make perfect copies of whatever the master does. This meant you could spread out all your read requests, people just browsing your site across a whole fleet of cheap servers. For the dot-com boom, this was an absolute game changer.
But that was really just the beginning of the story. It kicked off this whole journey of innovation. As you can see, we start out with that basic master-slave model, which was all about getting big fast. Then, we move on to something called semi-synchronous replication, where the focus started to shift towards making sure your data was safe. And finally, we get to the modern era of high availability with group replication and InnoDB cluster, which is really all about resilience. But see, that first model, it had a catch. A really big one. The whole process was asynchronous. Now, what that means is when you wrote some data to the master, it didn't wait around to see if the slaves got the message. It just said, yep, got it, and moved on, figuring it would send the updates over to the slaves whenever it got a chance.
And this created the classic and super annoying problem of stale reads. Just imagine this. You post the perfect comment on a blog. The master database saves it, and you immediately hit refresh to admire your work. But your browser gets sent to a slave server that hasn't gotten the update yet. And from your perspective, poof, your comment just vanished into thin air. The slave was serving you old, stale data.
This delay actually has a name, replication lag. And trust me, it was way more than just an annoyance. What happens if the master server completely crashes before it sent its latest changes to any of the slaves? Well, that data was just gone forever. Think about what that means for a business. Lost orders, lost user info, a total loss of trust. And failover? It was this terrifying, totally manual process. We're talking late-night emergency calls and running custom scripts, just praying you could promote a slave to be the new master without losing a ton of critical data. So this whole first era was really a classic double-edged sword. On one hand, it unlocked the web. It made it possible for startups to scale their apps on cheap hardware, which was a massive, massive win. But on the other hand, it created this constant low-level anxiety about data consistency, about reliability, and about that ever-present fear of a manual failover that could just take your whole service offline.
Right, so obviously the tech world couldn't just run on hope and a bunch of custom scripts forever. The next big step in MySQL's evolution was a direct response to this risk. It was a real shift in priorities, a quest for data safety, even if it meant giving up a little bit of that raw, blazing speed they had at the beginning.
And this brings us to semi-synchronous replication, which showed up in MySQL 5.5. This chart just lays out the trade-off perfectly. Instead of the master just moving on immediately, it would now actually wait for at least one slave to say, hey, I got the data. This meant your writes were a little bit slower, sure, but you got a huge leap in data safety. You were guaranteed that your data existed on at least 2 different machines before you told the user everything was okay. Problem solved, right? Well, not quite.
Even with semi-sync, there was still this massive vulnerability lurking in the system, the single master. It was a single point of failure. If that machine went down, your application still couldn't accept any new data. So the next evolutionary leap had to be a complete rethink of the architecture, a fundamental shift away from that leader-follower model to a more democratic group of peers. This was the real push towards what we call high availability, keeping the lights on no matter what happens. And this happened in 2 main stages. First came the core technology, group replication. It uses something called a consensus protocol, which is just a fancy way of saying all the servers have to vote and agree on every single transaction before it gets committed. This gives you fault tolerance, the ability to just shrug off a server failure. If the main server goes down, the group can automatically elect a new one in seconds. Then, InnoDB cluster came along and packaged that powerful engine with a smart router and other management tools to make it all easy. It's like they built this incredible engine and then built a super easy-to-drive car around it, delivering high availability right out of the box.
And this quote just nails the ultimate lesson from this whole journey, doesn't it? Early on, everybody was obsessed with scaling for speed. How can we handle more traffic? But what we all learned, sometimes the hard way, is that true scale is really about resilience, the ability to survive things going wrong. And you just can't have real resilience without automation.
So let's just quickly recap that entire journey. We started with basic replication, which was all about speed and getting big, but it sacrificed consistency. Then semi-sync came along and gave us a better balance, adding a much-needed layer of safety. But the real revolution was group replication, which brought true fault tolerance, and was finally all packaged up as InnoDB cluster, making high availability just a core built-in feature of MySQL.
And that really leaves us with this final thought. Over decades of evolution, the whole focus shifted. It went from just making things bigger and faster to making them fundamentally stronger. Because in the world of data, resilience isn't just some nice-to-have feature you can check off on a list. It's the entire foundation that everything else has to be built on.